less than 10 seconds.
Hey everyone, Michael Unger here from the H.R. McMillan Space Center, once again joined with Let's Talk Science, Morgan. Hey Morgan, how's it going?
Good. How are you?
Oh, I'm just doing fine. So this week, our theme is living in space. And as always, with Let's Talk Science, we've got a really cool activity, which is actually a program that Let's Talk Science has been working on for many years. It ties really nicely into living in space, specifically eating in space, and a really cool project that Morgan, you get into in a really cool video.
Yes. So this week we're talking about our project called the Tomato Sphere Project, which is really an excellent resource for educators, even educators who are implementing virtual classrooms. Well into September, they're able to participate if they would like. And what Tomato Sphere is all about is planting seeds for tomatoes that have been to space, as well as seeds for regular tomatoes that haven't been to space, and seeing whether or not they germinate and having their students speculate on what kind of conditions of living in space might influence the germination of those seeds compared to the regular seeds.
So I just want to be clear with what you just said there, Morgan. Did you just say these seeds have been in space?
These tomato seeds have been to the International Space Station. So
Oh my
a
God.
few years ago, yes, we launched this program and we sent some seeds up into space to look at, again, how the conditions up there really influence different physiological aspects of life. So things like temperature and humidity, do those things influence the ability to grow plants? And could that be related to how they influence the humans up there?
Well, that's awesome. So before we get into your video about the Tomato Sphere project, as always, Morgan, you were able to dive into this subject. You was able to tickle your curiosities about eating in space. Did you come up with any questions or wonders about eating in space?
Yeah, so I've always kind of fantasized about being an astronaut. And one thing that really holds me back is that I consider myself to be a little bit of a foodie. And
Okay.
I don't particularly think that astronauts get to dine well while they're up on the International Space Station. So this week I thought about that and I actually looked up what astronauts do get to eat
Okay.
and found out something pretty pleasantly surprising. So they actually eat a lot of the same foods that we eat down here on Earth.
Mhm.
And the foods are dehydrated or packaged in such a way that can be rehydrated and prepared almost to the same kind of foodie standards that someone might have here on Earth.
The only caveat to that is my palate is a lot of breads, and astronauts don't eat bread because, as we know, it's kind of crumbly, and any kind of crumbly foods don't really mix well with with being in a low gravity environment like the International Space Station.
Why?
Well, because if you were to bite into a piece of bread, the crumbs would start to float around and they would get into the instruments, and that's not good. They like to have the International Space Station very pristine and clean. You can imagine anything, even, water, they drink out of a straw. They don't want all that stuff floating around. Things would get very, very messy very quickly if you were eating messy foods. Same thing with potato chips. Potato chips, not good. Cookies, also not good.
Well, that's kind of crummy news. Imagine getting one right in your eye or something as well. Forget about the equipment.
Yeah, they have to make you have to make some sacrifices if you're going to go up into space, but they make substitutions, and so instead of breads they use tortillas. Tortillas are not as crumbly, so you can get close.
Taco Tuesday, Tomato Tuesday.
There we go. That's a great segue into our video this week. Enjoy. Let's Talk Science. Tomato Sphere.
Enjoy. This week we're exploring all of the different variables in space that affect how astronauts live at the International Space Station and what kinds of effects that these might have on the bodily processes of these astronauts, as well as all of the conditions that influence the ability of the equipment that we need on the International Space Stations and on spacecrafts during flight in order to safely operate and complete all of the missions that we operate in space. So with Let's Talk Science, we've developed a program where we can look at life in space through plants and through planting our own space tomatoes in our gardens, in the classroom and at home, and seeing how well these space tomatoes are able to grow compared to some regular tomatoes that haven't gotten the chance to go up to space. So yes, you did hear that right. We have sent tomatoes or tomato seeds to space on the International Space Station. And these seeds, they went up, they came back down. Now we've got them, and we can send them out in a partnership with a consortium consisting of the Canadian Space Agency, Let's Talk Science, Heinz Tomato Ketchup, and a few other partners. We have a program, the Tomatosphere program, where we send out these seeds as well as some control seeds, the regular seeds that haven't been to space, to educators. And it's a really, really simple 6-step process. So if you are an educator who is interested in having your classroom participate in the Tomatosphere program to look through the process of scientific inquiry at how space conditions influence life, it's really easy. I'm going to walk you through the process today. I'm going to show you some of my very own space tomatoes that I've planted in my garden. Like I said, all it takes is 6 simple steps. Step number 1 being you've got to go onto our website, letstalkscience.ca, and register as an educator in the Tomatosphere program and order your seeds there. Step number 2 is to look over all of the materials once you receive them in the mail, which you are able to still do for September, regardless of school closures because of COVID. If you are an educator who is even hosting virtual classrooms, you can sign up for these seeds and we will send them out. There's a news posting on the website where you go to order the seeds and register that tells you all of the details about how the process might be influenced because of the current circumstances. But if you're not, you are still able to do this. The website was down for maintenance on May 18th, but by the time this is airing, I'm sure it will be back up. Don't be alarmed if it is down for maintenance. It'll be up and running in no time. So once you receive your things in the mail, step number 2, review all of the materials and make sure you've got everything you need. These include the seeds, of course, which you will get 2 packets of with different letters labeling the 2 packets so you can differentiate between your space tomatoes and your regular tomatoes. And you've also got to collect soil pellets to plant the tomato seeds in and watch for germination or sprouting of the plants. And you should also have some sort of material, cue card or some sort of garden sign to label the 2 different plants that you have planted, the 2 different types of seeds, according to the letter that was on the packet that you received in the mail. Now, you will also want to encourage your students to form a hypothesis and ask questions about the experiment to teach them about scientific inquiry. So if you're a student watching this, some of the questions you might have, some of the questions I had when I was planting my own seeds were, does temperature here on Earth influence the germination of seeds? So what you could do is with some of your seeds, put them at different places of different temperatures. So I might have a plant in my windowsill that reaches around 24 degrees Celsius at any point during the day. And I might also have a plant in my kitchen on my counter that really stays cooler. It's only around 18 degrees Celsius all throughout the day. 4 degrees Celsius difference, that's massive. And see if one plant grows better than the other or if one plant just germinates and the other doesn't. And these kinds of questions are called hypotheses and are really fundamental to doing any sort of science experiment at all levels of science. kindergarten through grade 12. Beyond that, I still form hypotheses in the work that I do today as a graduate student. Really important and a really fun place to start. So some things that educators might need as a material in order to get students forming these hypotheses are things like pens and papers. Maybe you could form a large chart where you can record the predictions of different groups of students, whether seeds A will germinate and seeds B won't, or whatever it is, and you can actually track the germination of the seeds over time. So, step number 4, it's time to plant the seeds. You've got all your materials, you've got all the things that you're going to need, your predictions written down somewhere, recorded, and now you plant. And the planting process really depends on who you are as a home farmer or home gardener. What I do is take the seeds and just put them into a little pellet of water, or a pellet of soil that I've hydrated with some water, and then put that in a potting plant in the different environments where I want to grow my seeds. On my patio, in my windowsill, on my kitchen counter. Step 5, you observe and record the germination in the chart that you've maybe articulated with your classroom. And step 6, this is the best part, you submit your results online. So after a few weeks of the experiment proceeding, not even a few weeks, you can start to see germination within a few days sometimes, depending on how lucky you are and how green your thumbs are. Submit your results online, and this way we're able to track nationwide, between Canada and even in the States this program is available, how well seeds that have been to space are germinating versus seeds that have not been to space. What does an even better job is just looking at the website itself that we have here on letstalkscience.ca. So you go on your computer to our website and you scroll down, and we've got all the steps outlined over here on the left side of the screen, as well as a really great video that I'm going to show you about how to get this up and going. So. Now, my tomato plants have been deposited into a larger pot since I initially started planting my tomato seeds. And so my plants are looking pretty hardy and pretty healthy. There are these tall guys in this planter, and there's a few other little flowering plants in there, but these two are my tomato plants that I've kept over time. They started out in a smaller growing pot, something like what we saw in the video from our website, but I've since transplanted them into here, and I'm really hoping for tomatoes this year. Although the plants are growing and germinating, I have a really shaded patio, so it's not great for growing actual fruit from the plants, but fingers crossed, maybe this year will be my year. Maybe I'll find a sunny corner on the patio and actually stick my plants up there. Again, not the greenest thumb ever, but not only is the Tomatosphere program great for exploring the effects of going to space on the physiology of the tomato seeds, but also we are able to explore our potential to use plant life to sustain human life in space. So plants, of course, they engage in a process
of autotrophy, which means self-feeding, and they do so through photosynthesis. Through photosynthesis, they incorporate carbon dioxide from our air into oxygen, so they recycle carbon dioxide, which we breathe out after we consume oxygen, back into the oxygen we need to consume. And so, of course, space is a very oxygen-limited environment. It's got no atmosphere as we do here on Earth that is able to provide that oxygen to us. And so this sort of process of sourcing oxygen in space is a big question for us in being able to sustain life out there in the universe.
So that's all for this week. Me and my colleagues here at Let's Talk Science really look forward to seeing your tomato plants if you grow them, if you're an educator and you actually sign up and participate in the program, what you think about the experiment, what kinds of questions you ask about life in space and the conditions up there, about temperature, changes in humidity, changes in light, and you post in the comments below your results or how things go. You submit them online and really take advantage of the opportunity just to explore the conditions up in space. So, for example, look into the different sorts of temperatures that astronauts might be exposed to when they're on the International Space Station. Like I said, here on Earth, we tend to fluctuate by just a few degrees, like 4 to 10 degrees of a fluctuation at any point in the day, depending on where you are. On the International Space Station, the fluctuations are much greater. So when the space station is facing the sun, that part of the station or other spacecraft that astronauts might be traveling in can reach temperatures of up to 121 degrees Celsius. Whereas when they're on the far side, further, they can actually experience temperatures as low as negative 150 degrees Celsius, which is nearly a 300 degrees Celsius temperature range, which is wild. So ask yourself, how might those things influence their bodies and influence our potential to actually live out in space. We'll see you guys next week. Until then, stay safe at home. Enjoy your gardening experiment.